Alex, and this is my research partner.
Good afternoon, I'm Niyi from Central Michigan University, edited by Swansea.
And our project is Factors Affecting the Infestation of Canada Thistle by Urapora Karjwa. So, to give you a little background on Canada Thistle, it was native to Eurasia, and it's an invasive species. Its native habitat included all of Eurasia, from the Pacific to Atlantic, and north-south from Scandinavia all the way to India. So clearly a generalist, making for a pretty good invasive species. So with human advances in trade and transport, it was introduced to North America, into Canada in the 15th century, likely through crop seeds. And by the 20th century, it was the most commonly listed noxious weed in North America, and it had invaded most every herbaceous community. So the main reason why Canada thistle is such an effective invasive species is because of its means of reproduction. So one of the most effective means by which it reproduces is by vegetative reproduction. So it can form new individuals by this rhizomatous root structure you see here, and new individuals can form from root fragments as small as 20 centimeters as well. And it's also able to produce by seed production. And although its seed production or distribution isn't as extensive as some invasive plants, that's largely offset because of the longevity of the seed bank. It actually has a longevity of about 25 years, so a quarter of a century they can sit dormant. And that's me holding some Canada thistle. And, alright, so our project mainly focuses on finding a suitable biocontrol to reduce Canada thistle populations. So, biocontrol, because physical and chemical control are largely inefficient. Physical, because that rhizomatous root structure, it's got a very extensive root structure, so when, say, hand pulling were attempted, the root fragments will still remain in the soil and produce new individuals. And herbicides, so chemical controls, aren't very effective because they're very costly and very expensive, and there's concern for neighboring plants. And they're costly because the longevity of that seed bank, it requires multiple applications for a long period. There's also concern for neighboring plants applying herbicides. So one of the suggested biocontrols for the thistle is Urapora Karjwa. So the fly has been suggested to be species-specific, even in the absence of Canada thistle, so it will only parasitize the Canada thistle, and it's even been suggested to parasitize a different species of invasive thistle, bull thistle. So the means by which it reduces thistle populations is it lays its eggs on the thistle stem and induces a gall to form where the larva develops. And that acts as a resource sink, reducing flow through the water transportation through the vascular system, and almost total seed failure. And this picture of the gall, picture of the fly. And that's me. I tried to uproot one of the thistles, but as you can see, roots broke off. So.
Okay. So we know Urapora Karjwa is an effective biological control agent that will reduce the density of the Canada thistle when it's released. We also know it's species specific, meaning it will not also affect other plants within the same release site. But what we do not know about Urapora Karjwa are what factors attract it to the Canada thistle. And that specifically is the question our project will answer. Our project is basically focusing on modeling the factors that impact the infection rates of the Canada thistle by the Urapora Karjwa. In a nutshell, what attracts the insect to a particular plant and not another plant. A couple of the factors that we would look at are the height of the plant, the density of the plant, number of seed heads on the plant, and number of flowering parts on the plant. How we plan to do that, the first step would be to search the property and identify the locations of the candidate thistle on the property. Basically, we'll be walking in transect through the prairies, through the fields on the property. Once we spot a candidate thistle, we record the location with the GPS, record the total area of where the candidate thistle is with the GIS. Shout out to the game. Next thing we do is measure the density of the plants by placing a 1 meter square quadrant, which is right in this picture, in 6 randomly selected locations. From that, we get the density of the plant and multiply that by the area of the patch that we got using the GIS software. That gives us an estimate of the number of plants in a particular patch. And the next thing we do is select some sites to release our biocontrol agent, Europhora Coda, which will be our release sites, and select some other sites as our control agents, which we will not release the insect into.
So, looking forward, after we released the Europhora into the experimental sites, we'll be going back to the release sites and finding with GPS where we laid the quadrats during those density measurements and examining how many of the plants that were in that quadrant when we first laid it are now infected to get the infection rate in that release site. And we'll also be harvesting infected plants and uninfected plants from the research site, as well as plants from the control sites. And we'll be taking those back to the lab, drying them, and weighing them to, we'll be running an ANOVA on those 3 classes of plants, uninfected and infected from the release site and the control site, and to determine the effect of Europhora on biomass accumulation. And we'll also be running a logistic regression to build models based on those physical characteristics of the plants that we had harvested, such as high number of seed heads. And during the infection period, we'll also be evaluating the survival of Europhora cardui. We'll be running continuous sweeps with sweep nets through 4 transects along the longest axis of the release sites. So, as you can see here, this is the property, and these orange little patches are some of the places we've found candidate thistle thus far. So as we've been looking for candidate thistle, we've also been marking with GPS the location of bull thistle, that other invasive species, to aid management efforts of invasive species of PCCI. That's the blue little asterisk looking guys. And we've also been measuring the locations of various native species. That's the native species of thistle. Those are the little crosshair looking guys.
Okay, so far we've been through a number of phases of the property, and so far the candidate thistle patches that we found were located in the fields and the prairies that were recently disturbed. By disturbance, we mean they were either burnt or herbicide were released to the prairies. These are where we found the most mature and the highest densities of the candidate thistle, and we mostly found them in spots that are really close to either the roads, the trails, basically passageways. So this is a quick picture showing an example of disturbance, and that's us thinking of the correlation between disturbance and candidate thistle density. Okay, so like I mentioned before, we've been to a couple of ferries, been to the Midwest ferry, they've been to the Northwest ferry, the Midwest ferry, been to the Southwest ferry, and if you observe the picture, candidate thistle, which is illustrated by the yellow or the orange color, the majority of the density of the patches that we found are close to the roads, really close to the roads. And additionally, the bull thistle also, we found the bull thistle density to be the highest in the prairies that were recently disturbed. The southwest ferry, which is the ferry down here, was not recently disturbed, and that's where we found the lowest density of the bull thistle. This may suggest that there's a possible correlation between disturbance, proximity to passageways such as trails and roads, and presence and establishment of the Canada and the bull thistle. That's really what our observations have shown us so far.
So we've also been noticing some stratification between the types of density of the Canada thistle patches we've been finding. So we've only really been finding high density and low density patches, not really any medium density. So the high density patches are likely due to vegetative reproduction because they're very close together, very mature individuals, and the low density patches are typically younger individuals and likely due to the results of seed dispersal. So because vegetative reproduction is the primary means by which Canada thistle achieves such high density, such dominance in its introduced ranges, simple physical control really isn't enough to control it. The root system is just too extensive to be uprooted, and any physical controls are going to leave it behind to form new individuals. And as we said, herbicides are largely too costly to use and require multiple applications over a long period of time, so fairly impractical. So basically, biocontrol is a good way to go about controlling Canada thistle populations. And that is about it. That's us making the presentation at the local brand. Does anyone have any questions? We'd love to take them. Yes.
I'm just a little unclear how you guys were going to determine which patches to release the parasitic fly. Is that going to be randomized or stratified for the high density versus the low density? I was just curious about it. It's kind of an experimental design question.
Right. So the reason that we're doing density measurements at each patch is because we're still going through the prairies. We haven't found every single patch that we're going to find yet. But once we do, we'll be drawing up 15 release sites, isolated release sites to release the insects in. And we'll be using the density of the plants in those sites to determine how many insects to release in there. So say we have the area and we have the density, so we can calculate roughly how many plants are in each patch. So we can make a judgment on how dense that site is and release a proportional amount of insects. So we haven't necessarily worked out the number of insects per plant yet, but that's what we'll be doing once we get every single site found. So, if that makes sense.
One of the things I think he was also wondering how you were going to decide which ones were going to get or which ones were going to get the insects versus who was going to survive, not get the biocontrol guys.
We really haven't decided which ones will be release sites or control sites yet, but
But basically we have 15 release sites. 15 release sites should be comprised of the low density, medium, and high density. That we have yet to figure out yet, because once we go through all the prairies of the company and identify each population, we will then be able to classify each population into either high, medium, or low density. But 15 release sites, 5 control sites should have an equal proportion of low density, medium, and high density, both the release and the control sites.
if that makes sense. Yes.
Just curious about the life cycle of the fly and what season or when it's expected to be most effective.
So it's actually supposed to be most effective during the bolting period, I believe, right?
Yeah, it is. It is basically when between the bolting period and when the plant begins to flower, that's when it's mostly active. That's when it lays the eggs into the plants. That's the most active period of the fly.
And if all goes well, we'll be releasing them by the start of next week, or by the start of the week after next week, or by the middle of next week, because the plants have actually started to, they're not flowering yet, but the reproductive organs are formed, and yeah, they should be on time with that. Yes?
The flies that you're going to be releasing, do they bite?
I don't think we know.
Yeah, I guess we'll find out.
Oh God, no, they're species specific, there won't be lots of us.
Eggs are.
Yes.
Are there native populations of these flies, and are you looking for those as you are looking through your thistles, especially on sites where you aren't releasing them?
We have been looking at the insects we've been finding on the plants, but we haven't found any of the Europhora on them yet. So. But no, they're actually not native to this. They are not, but if they're species specific, they should either go extinct when the Canada thistle goes extinct, or at least only